I was showing one of the programs of polling, okay, and in that the program was having some small errors. Anyway, so the idea was just to give you a brief about polling technique using subroutines, and I didn't made that program in a very serious way. Okay, so now I believe the program is correct. So here in the previous class we were having jump. Okay, so definitely jump is not going to give you a return. So you call the device one. For the device one you call, you reach here in the subroutine call one. Okay, so dev one is your subroutine. This particular is your subroutine, and from there again you are calling in interrupt service routine ISS1, interrupt service routine, or ISS1. Then after that executing that program, your program will generate a return because this was a call. So it will generate a return. You will reach here. And from there you will call jump exit. Exit will reach here and it will, because there were 4 push. Okay. So definitely there will be 4 pops. Okay. And I believe you remember what push and pop is. Push is used to store the data into the stack pointer address, and then pop is to retrieve the data from the stack. So this is putting the data into the stack, and this is pulling the data from the stack. That is called pop. So after exit you will have interrupt enable and return. Why are we calling it return? Because we generated a call from here. So after the all the instructions you will have a return, and return will go to the next address which is here. Okay, so return will jump here. Okay, from this particular return, and then you will have the next call. You go to the next device, and then from there you will have another call where you will generate a call to the interrupt service routine 2. You will execute the interrupt service routine 2, then return, then again you will jump to exit. From here you will jump to exit, and so on. Okay, anyway, so this was just a brief about how we can have our polling technique when we are using subroutines. Okay, so I'm just briefly going through all the slides. If you have any doubt in that slide, please raise the question. So this was the way by which you can connect multiple devices to 8259, and 8259 is interrupt controller. That means he will manage the interrupts. So here you have IR0 and here you have IR7, which will make note of all the interrupts which are coming from different devices. Then this 8259, when it receives an interrupt, he sends an interrupt to the 8085, and 8085 replies by INTA. Okay, then we discussed about the pin diagram, where we discussed about how many data lines are there, how many interrupt lines are there, cascading lines, uh, slave programmer program, and enable line. Then you have interrupt acknowledge, which comes from the 8085, which is input, and interrupt, which is output, which goes to the 8085. Then we have A0, which decides that means A0 can be only 0 or 1. Okay, so that means there are only 2 addresses which we can access in 8259, which one we will call it lower port, low port, and high port. Okay, so if A0 is 0, we are accessing lower port, and when A0 is 1, we will be accessing high port. And then chip select is there to access the chip and all the rest of the things we discussed. Okay, now then we discussed about what is INTA, acknowledgement cycle. In that, when the interrupt is generated from 8259, the 8085 generates interrupt acknowledge signal, and okay, it can be a handshake and all those stuffs are there. Clear? Okay, now there are also possible ways to, there are different possible ways to connect multiple 8259s in cascaded way. Okay, so in cascading, what we can do is, for example, we had IR0, IR7. Okay, IR7. So what we can do is we can further connect. Uh, we can further connect 8259 to these interrupt pins. Okay, that means these pins, these ICs will act as slaves, and one of the IC will act as the master. To decide whether it is slave or master, we can check the SP/EN line. Okay, so we'll come to discuss that. We will discuss that when you are discussing ICWs. Okay, then after that, okay, this is simple interfacing where you have all the devices directly connected to IRs. So there is no cascading in this case. Okay, so there was one more information that we shared, that with cascading we can go up to 64 devices. So if we are connecting all 8 slave ICs, then each slave IC has got 8 interrupt pins. Okay, interrupt pins. So 8 into 8 will give you 64. Okay, so 8 ICs, 88259 IC, with each providing you 8 interrupts. Okay, so you can have maximum 64 devices which you can connect with different interrupt priority levels. Okay, because 64 devices means 64 different priority levels can be managed. All this we have to discuss how and all. Okay, then okay, we discussed about this block diagram where we said that, okay, first of all, the device will provide an interrupt through pin IR0 to IR7. When the interrupt is received by 8259, okay, this is the block diagram of 8259. So when the interrupt is received by 8259, it will go to the interrupt request register. Okay, so now, depending on the priority of the interrupt will be served. For that, there is one block which checks which priority should be resolved first. Okay, so simultaneously, suppose if IR1 and IR6 are entering into the interrupt request register, or they are requesting the interrupt, in that case only IR1 will be provided the interrupt before IR6, because IR1 has got higher priority. So remember, highest priority is IR0 and the lowest priority is IR7. Okay, so IR1 will be provided the first it will be provided the interrupt, and then by that time we know that IR6 is pending. So in service routine, register will maintain that, okay, I am providing this particular register request, so he will disable this request till until unless the particular request has been completed by the 8085. So that will be disabled for that time period, so that there cannot be any another interrupt on that line until unless we finish one interrupt. So remember, when 8085 is doing the task of any interrupt, in between that there should not be any interrupt coming to interfere it. Okay, for that we have to disable that particular interrupt. Okay, and it is possible to have, for example, it is possible that we had a device which is connected to, okay, we have suppose IR3 and IR6. Okay, they both arrived at t equal to 0, time t equal to 0. Okay, so we can directly see that IR3 is having higher priority. Okay, higher priority, this is having lower priority, so IR3 will be served first. Clear? So IR3, suppose, is being served by the microprocessor. Okay, microprocessor is serving IR3. In between that, assume when IR3 is being served, definitely this particular is pending. Okay, pending. Assume that while IR3 is being served, IR2 arrived. Then what will happen? Okay, please try to understand. At t equal to, assume t equal to t1. Okay, IR2 arrived. At t equal to t0, we had IR3 and IR6. So IR3 is being served by the microprocessor 8085 and IR6 is pending. Assume IR2 arrived before this particular interrupt service routine is finished, because assume this particular takes to a location interrupt service subroutine. Okay, in that case this subroutine is taking time from t0 to t5. It assume it needs 5 clocks to complete or 50 clocks to complete this subroutine. And in between, like we can see here, at t1 there is another interrupt arrived from IR2. Okay, so what will happen in this case? What will happen? There are three options. Like, the microprocessor will stop serving the interrupt IR3 and it will jump to IR2. Second option, microprocessor will continue with the IR3 service routine and after that he will give IR2, okay, the service routine. Or IR after IR3, because this was pending before and IR2 came later, so IR6 will be served first and then after that IR2 will be served. By that time IR2 will be kept as pending. So which are the options you think are correct? What might be happening when there are multiple interrupts coming at different time with different priorities? How the microprocessor will serve those interrupts? Any idea? What will be the solution in this case? At time t equal to 0. बोलिए.
Sir, aging
So second
concept.
option.
Hmm? Tell me what will happen if IR3 is being served, IR6 is pending, IR2 came after IR3. What will happen?
Sir, first IR3 will be served, then IR2, then
So
IR6.
you mean to say first finish IR3, then after that only go to IR2, and then you can go to IR6. Anyone else? Anyone else with any other logic? This is the first option. Anyone else? Anyone else with any other logic? If not, then okay. Remember, when any higher priority interrupt comes, even while being any other lower priority interrupt being served, in such case, okay, the higher priority will get the 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 chance to be served first, and automatically IR3 will become pending. Okay, and then IR3 will be served, and then after that IR6 will be served, which will be also in pending mode. So these are the things that we have to keep in mind, that in between any particular interrupt service routine is being served, if suppose a higher priority interrupt comes, then in that case the lower priority interrupt will be halted or pending. It will go to the pending mode, and then first the higher priority interrupt will be served, and only after that the pending interrupts will be served. Okay, this is important. Remember, ISS, when we are saying interrupt service routine, it is not a one line code. It will be somewhere on 5 to 10 line code. So there will be definitely 5 to 10 opcodes. So suppose here you have opcode number 1, opcode number 2, opcode number 3, and so on up to opcode 10. Okay, so assume here in this time when opcode number 2 was being completed, then in that case IR2 arrived. Okay, so remember this particular instruction has been completed. Remember, only the most important thing is the instruction should be completed. And after that, if suppose in between, after that instruction is not, the service routine is not completed, only the instruction is completed. Okay, not the service routine. In between, another interrupt came which has higher priority. So what will happen after completing the present instruction? This particular so-called no, not 2, 3 will go to the 3 will be saved in the stack pointer, and then this particular interrupt will be served first. Then after serving this interrupt, the microcontroller will go and check what is the stack pointer's content that is pointing to pin number instruction number 3. It will come back to instruction number 3, and then it will execute the, this is your IR3. Okay, so it will execute that first. Okay, then IR6. So this will be the correct option. That means first he will serve the higher priority. Even in that case, he will first complete the present instruction in the ISS. Okay, and then he will store the next next instructions location in the stack pointer. First serve the higher priority interrupt, then serve the pending interrupts. So remember, this is how the interrupts are being managed. Any doubt in this particular thing? Okay, now, so in service routine, register will hold the information about the present interrupt being served. Okay, interrupt mask register. In this, you can keep or you can mask some of the interrupts. Like if suppose I am trying to mask IR4 and IR5. Okay, IR4 and IR5. In that case, what I can do is, in this particular register, I can make them masked by putting 1 1. So it will be 0 0, so 4. So 0 0. Okay, so 7 6 5 4. 4 is 1. Okay, okay, 4 is 1. Oh, sorry. So in that case, when if I want to make IR4 and IR5 masked, then in that case 7 7 6 5 4 3 2 1 0. So this means the IR4 and IR5 are masked. Okay, so that means even if there is any interrupt coming from these two lines, IR4 or IR5, they won't be served by the 8259. So we can mask any particular interrupt line also using interrupt mask register. So the most important task is done by this particular priority resolver. How it resolves? It checks first which of the interrupts are requesting the interrupt service routine. Then after that, he checks which service in service register which particular interrupt is being served. If that interrupt is of lower priority, then he will stop that and he will give the chance to the higher priority interrupt. Clear? Otherwise, he will stop the lower priority interrupt for time being or keep it in pending mode. And after completion of the present higher priority interrupt, he will give the chance to the lower priority interrupt. And before that, before going to serve any interrupt, he will check the interrupt mask register to check whether that particular interrupt has been masked in the IMR or not. If it is masked, then don't serve that particular interrupt. Okay, so priority resolver is the most important decision maker. Okay, so that is why you can see that interrupt priority register holds the most important so-called bidirectional line. Okay, sorry. Then after that, we said we talked about data bus buffer, where you will load the data, whether it is the ISR's address and all. We will discuss how the ISR's address is decoded and all. And then we have control word logic block, where we can have read and write operation from the microprocessor. A0, which is the address bit, A0 can be A0 if it is 0, or it can be 1. So if it is 0, we call it low port. Okay, and if it is 1, we call it high port. Okay, so there are only two addresses which can be fetched inside 8259, which is low port and high port. Then we have cascade 0 1 2, which will be used only when we are using slaves, or we are using cascaded 8259 with the master 8259. And then we have SP and enable. Here I think the enable should not have any bar line. So if it is 0, if this particular line is 0, then we are informing the 8259 that there are slaves connected to the master line. Okay, and if it is 1, then it tells that this is the master and there is no slave connected to this. Okay, so slave, when we have to do slave programming, we will provide 0 to that line, and when we have to make it master programming, we will make it 1. We will discuss that also. Okay, so this was a brief about the block diagram. We talked about all these things. Okay, now coming to interrupt operation. So remember, to complete any interrupt, we have to go through two types of control command words. One is ICW, so initialization command word, and operational command word. We can call it ICW and OCWs. Okay, now after that, yeah, we discussed about this. So when any interrupt is generated through IR0 to IR7 line, in that case the 8259 checks these interrupt, and then 8259 interrupts the 8085 using INTR line or interrupt line. Okay, and we are saying it, when we are saying CPU, we are saying 8085. Then in response to the interrupt, the microprocessor has to generate another pulse, or we can call response. We can call it INTA, that is interrupt acknowledge. So it tells, the microprocessor tells the 8259 that I have received an interrupt. Okay, then after that, now this is the first interrupt acknowledge. Along with that, further two more interrupt acknowledges are generated by the 8085. So in the second interrupt acknowledgement, 8259 generates the, or loads the lower 8-bit address for the ISR, interrupt service routine. And in the third, that is, this is for the second. Okay, and in the third, the 8085 generates the 8259 generates the address of higher address bit for the ISR, that is the third INTA. So in the first interrupt acknowledge, when 8259 triggers or sends an interrupt to 8085, then after that, second interrupt acknowledge will be generated when 8259 sends the lower 8-bit address for the interrupt service routine, and third INTA pulse will be generated when the higher 8-bit address of the ISR is loaded to the data lines of the 8085. Okay, so in this way, the interrupt acknowledge 2 and 3 are used to find the complete address of the interrupt service routine. Okay, this is done. And after completing the call instruction, because remember call, okay, and after that you have to provide address, which is 16-bit address. So 16-bit address can be, we can say, 8-bit higher address and 8-bit lower address. Okay, so first is for first INTA for the call, that is the opcode for the call. Second INTA, INTA 2, INTA 1, okay, for the lower address, and INTA 3 for the higher address of the interrupt service routine. Okay, so after that, when the call instruction is completed, the system generates automatically end of interrupt instruction or a signal, or we can have not automatic, we can generate end of interrupt command, which is generated by the program itself. Okay, so there are two ways by which we can exit the interrupts. One is automatic end of interrupt, and second one is by passing a command end of interrupt using EOI command. Okay, so this is how the whole interrupt part is being served. And now the question comes, okay, we discussed about this, all these things. This is all we discussed, third INTA and all. Okay. Okay, now coming to the today's lecture. So there are two types of command words, types of command word. One is ICW and then other is OCW. But in ICW, there are four ICWs. Remember, there are four ICWs. So you will have to initialize ICW1, 2, 3, 4 if you want to use all the ICWs. Otherwise, out of those four, okay, out of those four, first two are essential. That is, only two are mandatory. Two are mandatory, and rest of the two are optional. Okay, so we will come to see when we can use these two optionals, but two are definitely mandatory. Out of four ICWs, two are mandatory and two are optional. Okay, and once is 8259 is initialized, OCWs are not needed to be issued in a specific sequence. So there are OCWs. Remember, three different OCWs. So three OCWs are there, but the sequence of OCWs are not mandatory. Okay, they can come at any time. That means you can generate OCW 3 first, then 2 or 1, or maybe 2 first, 3 and 1. So it is not necessary that you have to follow a sequence when you are using OCWs, but when you are using ICWs, you must follow a sequence. That means first the ICW 1 will come, okay, which will be followed by ICW 2, and then if needed ICW 3, and if needed ICW 4. Okay, so the sequence is essential here in case of ICWs, but sequencing is not essential when you are using OCWs, operational control words. We will come to see how these particular words are generated and what is the significance of these things. But remember, these two are mandatory, okay, and these two are optional. Okay, so now let us see the definition of these particular ICWs and OCWs and what are the roles when you are using the ICWs. Okay, now when 8259 receives the first INTA, okay, interrupt acknowledge from 8085, then 8259 sends opcode CDH. Okay, why CDH? Because CD is the command for call instruction. So the call instructions hexadecimal command is CD. Okay, so remember, first call instruction will be generated or loaded to the data bus, and then the lower address, then the higher address. The, so first is CD. Okay, so content of first interrupt vector byte will be always C and D. This is CD. Okay, CD H. Okay, and then, like I said, when the second and third INTAs are received by the 8259, it loads the higher and lower address bytes, lower and higher address bytes. Okay. Remember always the the third one. Okay, the third INTA will be always A15 to A8, which is higher address. Okay, higher 8-bit address. So now the question is, we know the status of the first INTA's reply, and we are confirmed that what will be the content of data line after the third INTA. But what happens in between that? What happens in between the first and third INTAs? So what is the reply the 8259 gives to 8085 when he has to pass the second, that means this particular INTA's reply? So remember, when the second INTA pulse is generated by the 8085, then the 8259 can have two different options, two different types of replies. One is based on whether the ISRs are kept at 4 bits separated. This might be very confusing for the first time. If you have any doubt, do ask me. I will explain it in a very, what to say, simple way. Okay. First INTA's reply we know, call. So therefore it will be CD, always CD, call instruction. Okay, call instruction. So there will be always CD in the first INTA's reply. In the third INTA's reply, it will be always A8 to A15's data. Which A8 to A15? Let us try to understand this. This is our memory. FF, FF, FH. Okay, starting from 0000H to FFFH. Okay, and we know that interrupts are generally kept in the page 0. Okay, so the page 0 will be from 0000 to 0FFFH. Clear? Now we are keeping ISR for any particular interrupt. Okay, interrupt service routine. We are keeping it in, when I am saying ISS, remember interrupt service subroutine. Okay, so interrupt service subroutine is written somewhere around 0300, assume. Okay, now the question is, we have to reach to this particular address 0300. Okay, let me make it more complex so that it will make more sense. Okay, assume the interrupt service routine is written at 0123H. So the address now can be decoded into two parts, 0, 1 and 2, 3. Right? So this is your higher order address of the ISS, and this is your lower byte of the ISS. Clear? Now when any interrupt arrives to 8259, interrupt is coming. Assume IR3 came to 8259. So definitely when 8259 receives any interrupt, he sends INT to 8085. And in that you have the data lines here. Okay, 8-bit data line or data bus. Okay, so in reply to INT, 8085 will send INTA. I am calling it INTA1. Okay, so when INTA1 is received by 8259, he will put 8259 will put the command for call instruction. So call instructions command is your CDH. So data line will get the data, first data that will be loaded will be CDH. So now 8089 receives, understands, okay, I have to generate a call instruction, right? By reading CD, 8085 understands that, okay, I have received a call instruction, but where to call? Now after the call instruction, this is your call instruction. After the call, you have to provide the address. Which address you are going to provide? The address of the subroutine, that is 0123. Okay, so now the question is, to reach to this address, the 8085 has to send two more interrupt acknowledge. So now it sends the int a2 and then int a3. And we are sure that whenever we are generating int a3, the higher address will be uploaded to the data line, that is 23h. Okay, so this was for interrupt acknowledge 1, and in case of interrupt acknowledge 3, automatically 23h will be loaded. That is the higher address, higher order address line. So it will be this, this will be loaded from a15 to a8. Clear? So
Sure,
hmm,
sure, but 23H is the lower byte in 0123H. So, sir, why should we load it
okay,
in?
sorry, okay, sorry. Okay, sorry. This is higher. Okay. This is higher, this is lower. Okay. ठीक है. So no issues. Sorry. This is higher, this is lower. Okay, clear. Any other? This is higher. Sorry, my mistake. And this is lower. So you will have 01 here. Okay, clear. Now what about the? This is for the third INTA. Now the question is, what is in the second INTA? So what are the details in 8-bit? What are the details which are sent through the data bus towards 8085? Okay, here also it will be 01. Okay, that's not an issue. Okay, so now the question is, what is the content of the data line when you are sending the, that is 0 1. What is the content of data line in reply to INTA2? Okay, we know that this is done call instruction, this is done higher address, but what is the content of the 8 bits, okay, for this INTA2? For that, remember, it is not directly going to load the lower address byte. So for that, in reply to the second INTA, first the in the 8259 we will load the sequence of whether the interrupt service routines are kept 4 bits apart or they are kept 8-bit apart at an interval of 8 bits. Okay, so we will come to that. Okay, so in such cases, when you are using 4-bit interval, you are going to use A5 to A7, and if you are using 8-bit interval, you are going to use A6 and A7. How we will come to see in the next slide. So remember, INTA 1's reply will be this one, INTA 3's reply will be this one. But let us see what will be the content of INTA 2's reply. So okay, so remember, first we have to put the command word for ICW1, that is the interrupt command word 1, and then you will have the second command word ICW2. Then there will be a question whether the system is in a cascade mode or a single IC mode. So now there are two options, that it can be cascade mode or single IC mode. So if it is single IC mode, then in that case we will say yes, it is single IC mode, go ahead. Otherwise what will happen? If it is in cascade mode, then you can escape ICW3 and then you will check ICW4 is needed or not. Again, there will be a question. ICW4 is needed or not. If not needed, escape that. If needed, then go through the ICW4. Okay. If needed, that means if ICW4 is 1, that is it is needed, then in that case you will have to put the value for ICW4 also, and then only you can start the accepting the interrupts. So first, anyhow, you will have to load ICW1 and ICW2. ICW3, whether it is needed or not, will depend on whether the system is in cascade or not. Okay, ICW4 is needed or not, then there will be a question. And how to know whether ICW4 is needed or not? Remember, we will specify that information in the ICW1, that whether ICW4 will be needed or not. Anyway, we will discuss what are the contents of all this ICW1, 2, 3 and 4. By that, it will be clear why it will be needed or why it will not be needed, and what are the bits content in all these 4 ICW. So remember, these are all control words. So first you have to fill 4 control words. Whereas in case of previous examples, there was only 1 control word. Here you have the same register. In that, first you will put ICW1. Then after that, you will load in that same register, you will put ICW2. If needed, then you will load ICW3. If needed, you will load ICW4. There are no 4 registers for this particular ICWs. In the same register, you will load the 8 bits in a sequence. So it is understood that first the ICW1 will come, following that ICW2 will come, following that if needed ICW3 will come, following that if needed ICW4 will come. So this is the sequence or the flow chart which is followed to design or to make the system ready to accept an interrupt. Okay. So now let us look into the ICW3 and ICW4 are optional. It is not mandatory. Now first let us check what is the content of ICW1 and why and how this particular command word is used. Okay. In case of ICW1, 2 things are mandatory. That is, A0 will be always 0 and D4 will be always 1. This will signify that ICW1 is generated. So A0 means, I told you, A0 will point towards lower port of 8259, a low port. So this command we can say is for low port. So A0 will be always 0 and D4 will be always 1. Okay. Now coming to the rest of the bits.
Sir,
Hmm.
sir, what is the meaning of low port here? Because 8259 has only one port.
Where is the port in 8259?
The
There is
data lines, maybe.
they are data line, they are not ports. Okay. So when we are saying port, we are activating internally one of the internal ports. Okay. It is not feasibly present in the outside. Okay. So we are using the internal 2 ports of the 8259. And when we are using A0 equal to 0, we are pointing towards the lower port or lower address port in that 8259. It is not directly given to the outside world. Okay. So it is internally managed. So remember, it is internally managed. You cannot directly access them outside. Okay. So when it is A0 is 0, we are accessing the lower port, and now there are 8 bits D7 to D0 for the command word. So D7, D6, D5 are used to check the address, vector address in case of 8085. Because remember, this IC can be connected to 8086 and 8088. But we are talking only about 8085. We will not be talking about how it is connected with 8086. It is a different technique by which 8086 is connected to 8259. We are only focusing on how 8085 is connected to 8259. Now, there are 3 bits A7, A6, A5. They will decode the vector address. Vector address means the interrupts interrupt vector's address. Okay, it will be used to decode that particular line. D4 will be always 1 because we are passing the ICW1. So A0 will be 0, D4 will be always 1 in ICW1. Now D3 will tell us whether the interrupt which is coming should be level triggered or edge triggered. So assume if you have kept 0 in the D3, that is edge triggered, then the system should generate interrupt only on the basis of whenever we gets an edge. Okay, edge at changing edges of the signal or the line. That means IR0, here you have 8259, and there you have IR0 and IR7 up to IR7. So now in this line, interrupt will be detected the moment you have any triggering from the edge itself. Okay, so if you are keeping D3 equal to 0, so it will just detect the edge and it will generate the interrupt. But if suppose you are keeping D3 equal to 1, in that case it is level triggered. Level triggered means it should be high for a certain time. It is not detecting only the edge. It should be high for certain time period, and corresponding to that the interrupt will be detected. So you can choose between the type of triggering by using ICW1. So D3 will detect the level triggering or edge triggering. So LTIM, level trigger interrupt mode. So if it is 1, you are using level triggered. If it is 0, you are using edge triggered interrupts. Okay, now the D2 line is for address, that means to call the address of the interrupt. Okay, so AD address interrupt. Okay, now this is important here. In the previous slide also we discussed about it, that there can be two types of sequencing for the ISRs. That means, or you can say ISS, interrupt service subroutines. That means interrupt service subroutines can be kept at an interval of 8 addresses. We will show that in the next slide. Or they can be kept after an interval of 4. Okay, so we can have the choice to keep the interrupt service routines after every 8 addresses or after every 4 addresses. Okay, if you can recall the okay, I will come to this. Okay, I will come to this with a simpler example. Okay, so if this particular bit is 0, then you are mentioning that all the interrupts are kept 8 after every 8 interval or after every 8 addresses. Similarly, if you are keeping it 1, then you are telling the system that all the interrupt service routines are kept apart by 4 intervals in the memory address. Okay, then the D1 will tell the system whether you are using cascaded ICs or you are using single. So if you are putting 0 here, because single, okay, when it is 1, it will be single. So single means you are using only one IC 8259. If this particular bit is 0, if D1 is 0, then you are informing the system that there is no single IC in this particular system. Rather, there are multiple slaves available in the system. So by defining this bit, you informs the 8085 that there are multiple slaves connected to my master IC. Then at the last you have IC4. That means whether you need the ICW4 or not. Okay, if we go to the previous slide. Okay, now okay, if we go to the previous slide, here you can see whether ICW4 is needed or not. I told you whether it is needed or not will be disclosed in the ICW1 itself. So ICW1 will have the information that ICW4 will be generated or not. So here in the ICW1 you can see the last bit D0 informs the 8085 that there will be ICW4 also. Okay, so if it is 0, if D0 is 0, so there will be no ICW4. If it is 1, then of course ICW4 will be coming after ICW3. Okay, so this is all the details of ICW1, which is interrupt command word 1. Okay, similarly there will be 3 more interrupt command words, which is interrupt command word 2, 3 and 4. Now this part that call address interval. Okay, why, what is this particular thing signifying here? So if you remember, this is 182. If you remember the interrupts, if you can recall the interrupts when we are talking about interrupts, um, where is the interrupt? Okay, you can see here the interrupts, right? Now from this you can see that RST 0 was at 0000, then it was 008, then 10, then 18. 10 is 16, remember. This is hexadecimal 10, not the decimal 10. So 0, then 8, then 16, and so on. So now you can see that every ISR's address is kept how many address apart? 8, 0. Then after that, next ISS is at 008. Then next ISS is at 010, which is 16. Okay, then 24 and so on. Okay, so now the question is, similarly, that means we have to specify the addresses of these particular interrupts. And similarly, when you are specifying the addresses of the interrupts which are being generated by 8259, then there are two options. One is you can keep the interrupts after every 8 address, or you can keep the interrupts after every 4 addresses. Okay, so let us check how we can decode that thing. Okay, now A5 to A15 will be definitely telling about the ISS details. Okay, we can come to this. Okay, so I told you that when INTA is generated, the 8259 first loads the call instruction, right? When the call instruction is loaded, and then we can specify in the ICW1 whether we are going to keep the interrupts at every interrupts at after 4 intervals or after 8 memory locations. Okay, so now suppose you are keeping you are using ICW1 and you are specifying that you are going to keep the interrupts after every 4 address. Okay, after every 4 address, then definitely you will be occupying a page of 32 addresses. Why 32 addresses? 4 addresses, and there are 8 interrupts. 8 interrupts, IR0 to IR7, right? So there are 8 addresses or 8 interrupts, 8 interrupts, and we are keeping each of these interrupt after every 4 address locations. So definitely 4 into 8, that means 32 locations. So you will be taking a space of memory address of 32 locations. So we will call it a page of 32 addresses. Similarly, if you are using the addresses to be kept 8 addresses apart, okay, then you will be using 8 addresses kept apart into 8 different interrupts. So the page of 64 bytes. Okay, so if you follow this, then you will be keeping the things after every you will take a page of 64 bytes for the the interrupts. Okay, I will explain this in the next slide. When you will see that, it will be more understanding than rather than reading the thing. Okay, now remember, we know that the call instruction has to provide an address, and address will be always 2 byte long. That means A02, A15 should be provided to the 8085. Now, how that particular thing is provided? When you are keeping 4 interval system or when you are keeping 8 interval system. This A5 to A15, A0 to A5, 862, we will explain this in the next slide. It will be more clear. Okay, we discussed that LTIM, if it is 1, then we will be using level triggered mode, or if it is 0, we will be using the edge triggered mode. ADI, address call, whether the address call are 4 addresses apart, or they are 8 addresses apart. If it is 1, we are using 4 addresses apart. If it is 0, we are using 8 addresses apart. Single, that particular bit informs the system that whether the IC, there is only one IC 8259 in the system, or there are multiple slaves in the system with 8259s. So if it is multiple system, then definitely you will be having slaves. So if there are slaves, definitely you will have to use IC3, ICW3. ICW3 will be used when there are slaves in the system. When we will come to ICW3, it will be very clear, okay, how to recognize which slave is generating which interrupt. Okay, so then we have ICW4. If the bit is 1, it will be ICW4 will be needed. If it is 0, then it is not needed. Okay. Now, first thing, how the interval 4, interval 8 is actually maintained and how we can decode that thing. Okay, we know that there are 8 interrupt lines, right? IR7 to IR0. These are your hardware pins of 8259, right? So 8259 has got IR0 to IR7. Now the question is, how the microprocessor will know the interrupt is coming from which pin? Okay, for that, in the ICW1, we can specify that I am keeping the interrupt service routines, or ISS, interrupt service subroutines, at after every 4 interval. So the IRR can be 0, 1, 2, 3, 4, 5, 6, 7. Clear? In that, remember, these blue lines are provided by the user. By the user means we will design the system according to which we can keep A7, A6, A5 according to our choice. Okay, so we can design the circuit which will provide the A7, A6, A5. Rest, red lines are provided by the 8259. So we don't have to worry about the red bits. 8259 will generate those red bits. So D7, D6, D5, they will be provided by the user. Okay, that will be provided by the circuit itself. Rest of the lines are 5 bits, D0 to D4. These are 5 bits which will be provided by the 8259. Now let us see how we can correlate this particular IR with the addresses generated by D4 to D0. Okay, so in this case, look here, 0. Okay, so you can see these 3 bits are 0, 0, 0. Okay, 1, 0, 0, 1. Similarly, if there is an interrupt generated from D6 or IR6, from the IR6, if there is an interrupt, you can see this is 6. So D4 to D2 will provide which particular line is generating the interrupt. Rest of the 2 lines, D1 and D0, will be always 0. Clear? Now let us see how this particular thing is getting more interesting. Okay, so remember there are 8 interrupt lines. To represent those 8 interrupt lines, we'll be using D4 to D2. They will tell which interrupt line is coming or which interrupt line is getting the signal. So 0 0 0 0. If it is 5 fifth pin, then it will be 1 0 1. Clear. Rest of the 3 bits D7 to D5 is provided by the user himself. It will be provided by the user. He will generate a circuit or develop a circuit which will provide the information of A6, A5, A7's data. Okay. Rest D1, D0 will be always 0 0. Now let us check why we are calling this 4 interval system. That means the ISR are kept 4 interval apart. Let us check this 4 bits. Okay, if we divide it 4 bit 4 bit 4 bit. Okay, so this is your upper 4 bit, this is your lower 4 bit. Okay, this is your lower 4 bit. Okay, in that case you can check here 0, this is 0. Okay, lower 4 bits, check the lower 4 bits. 0 4, right, 8, right, 12. You can convert it into hexadecimal also. This is 1100. Okay, so A B C. Okay, then after that, now you can see this is becoming 16. Why we are calling it 16? Assume this is 0 0 0. The user is providing 0 bit or design the circuit which will be activated only when 0 0 0 will be put. Now you can see 0 0 0 1 1 0. Okay, 1 0 in hexadecimal is 16. Clear? 1 4 1 8 1 and then your last so called C 1C. Okay, this is how we can decode that the addresses of ISS will be kept after every 4 interval in the memory address. So this is how we can decode this thing. Remember, first thing that we have to remember, when we are using 4 interval system, I simplified it 3 plus 5. I am writing it 3 plus 5 so that it will be helpful for you. 3 bits will be provided by the user. Okay, user. 3 bits will be provided by 5 bits will be provided by 80 to 59. First thing that you have to remember. Out of the 3 bits, A7, A6, A5, the higher 3 bits will be provided by the designer. He will make a circuit for that. Rest of the 5 bits will be added by the 8259. We don't have to worry about it. But how the 8259 actually generates those bits? So you can see there are 8 interrupt lines, A0 to A7. Oh, sorry, IR0 to IR7. Okay. Corresponding to that, you can see D4 to D4 to D2. These 3 bits will tell which interrupt line is getting the signal. That's all. D1, D0 will be always 0. So you can just decode these 3 bits and check what is the which particular line is getting the interrupt. Okay, these things are not provided in very much detail in the data sheet nor in the book. Okay, so D2, D3, D4 you can check 7 6 5 4 3 2 1. So with these 3 bits you can identify which of these lines are getting high. किसी को डाउट है? Okay, rest of the 2 bits will be always 0. Okay, clear? So that is why I am calling it 3 plus 5, if you can remember. Okay, because 8 bits will be there, 3 bits from the user, 5 bits from the 8259. Okay, so assuming A7, A6, A5 to be 0, if you assume these 3 bits are 0, in that case you can see it will be 0 0 0 4. Okay, 0 8, because you can divide it from here 4 bits for the upper 4 nibbles and 4 bit for the lower nibble. So 0, 0, 0, 4, 0, 8, 0, C, then 1, 0, which is 16 in decimal, then 1, 4, 1, 8, 1, C. Okay, clear? Any doubt when we are using 4 interval system, how these 4 interval bits will be actually arranged, and how the system or the microprocessor will know interrupt is coming from which line? Because remember, this information will be loaded in the data line of 8259 or 8085. Both are having the same data line. They will be interconnected. So from the data line, 8085 can decode that, okay, the address of the ISR is this. Complete address of the ISR is this, or this, depending on the interrupt which is generated from which pin. Now, from that, he can also easily identify from these 3 bits, he can identify the interrupt was generated at the pin number 4. Okay, so on. Any doubt till this part? Let us see what happens when the interval is 8. Okay, so if you have provided the data or the information in the ICW1 that you are going to use 8 interval system, in that case we'll be using 2 plus 6. So now the question is 2 plus 6. You can easily understand why I am putting 2 plus 6, because 2 bits for the user, 6 bits for the 8259. Now how the things actually changes. In any case, there are only 8 interrupts, IR0 to IR7. To represent these 8 interrupts, you just need 3 bits. So which 3 bits will be representing the interrupt lines? D5 to D3. These 3 bits will be used to decode which line is providing you the interrupt. Okay. So now you can check 0, 0, 0, 0, 1, 0, 1, okay, 5, okay, 2, so 0, 1, 0, 2. So here rest of the 3 bits, D2, D1, D0 will be always 0. Okay, now how can we call it 8 interval system? To call it 8 interval system, we have to divide this system into 4 bits. Okay, so I divided it into 2 halves. So this is upper 4 bits. Okay, this is the lower 4 bit. From this you can easily see the system 0. Now you see 0, 0. So 0. Then 0, 8. Okay, then 1, 0, 16. Then 1, 8, 24 in decimal. Okay, this is 1, 8. This is 1, 8 in hexadecimal. Okay, this is 0, 0 in hexadecimal. 0, 8 in hexadecimal. 1, 0 in hexadecimal. In 16 is decimal. Okay, then of course you have 2, 0. That is 32 in decimal. Then you have 2, 8 in hexadecimal. Then you have 3, 0 and 3, 8. Clear? So we are actually just decoding the ICW1. There are 4 ICWs still. Okay, 3 more ICWs to be covered. So out of that, we are just decoding how the intervals are actually managed. So this particular information tells that where the ISR or the ISS for that particular interrupt is kept. Okay, so we know that there is memory which is ranging from FF to 0, 0, 0, 0. Clear? So 0, 0, 0, 0 to F. Now the question is, how can the 8085 know that, okay, if this particular line is generating any interrupt, I have to go to that particular interrupt service routine, or where that address is for that particular interrupt service routine. Suppose we are assuming interrupt was generated in fourth pin. Clear? If interrupt was generated in fourth pin, then automatically you can see 00. Okay, so the address is 0010. This is 20h. So 0020. So the ISR will be here for the fourth interrupt line. Okay, next if you go, then 0028 will be the address for the, so this is for IR5, IR4, and it is not necessary it should be always 00. That these two bits are provided by the designer or the person who is designing the whole system. So A7, A6, like we have seen in the past how we can design our own addresses. Okay, so he will generate that particular circuit, he will connect it to 8259, and then you can automatically decode that automatically where this particular interrupt service routine should be loaded or pointed. Okay, now any doubt in this particular part? Okay, now what are the features of ICW1? We are concluding ICW1. Okay, so features of ICW1 is, from the ICW1 the user or the designer can know whether ICW4 will be generated or not. Yes, there is one particular bit which tells, that is D1, which tells that whether ICW41 will be generated or not. Second, the information that you can extract from ICW1 is that whether the system is a single 82598 based system or a system with masters and slaves, or we can say cascaded system. So this information can also be decoded from the ICW1 itself. Then we can identify the type of interrupt or the type of triggering that is going to take place. Whether the interrupt will be generated when a level based triggering will be generated or an edge based triggering will be generated. So depending on the type of triggering, we can that one can be also decoded from ICW1, that the system is based on level triggered systems or it is based on edge triggered system. And last but not the least, it also tells you that interrupt service subroutines, ISS, addresses are mapped in every 4 byte or 8 byte intervals. Okay, so these four informations, most important four informations, are provided by the ICW1 only. Then we can go and check what is ICW2, ICW3, ICW4. Any doubt in ICW1? Because after this ICW1 will be closed. Any doubt in ICW1? What is the information in ICW1? Why we need this thing and all? Remember, to make this 8259 work, you need ICW and OCW. In ICW, 2 ICWs are mandatory and 2 are optional. In OCW, these are always optional. Okay, there are 3 OCWs and 4 ICWs. We only discuss the first ICW only. Okay, now example. Now it is your task. Assume we need a system. Okay, we need a system where we need to configure 8259 in and using ICW1 with the following operations to be conducted. That is, we have to inform the system that there will be no ICW4. We have to inform the system that only 18259 is connected with the system. There are no cascading taking place. We need 8 byte addressing intervals for the ISS or interrupt service subroutines, and IR0 to IR7, all these interrupts are edge triggered. Okay, all these are edge triggered interrupts, so we have to detect the interrupts or based on the edges, then ls byte of fourth address should be of the IR0 should be 80H. So what should be the content of ICW1? First try to write your own ICW1 and tell me what should be the content of ICW1 so that we can meet all these 5 requirements. You have 2 minutes. Anyone? Anyone, what should be the value of ICW1?
So 12H.
First answer is 12H, 12H. Okay, anyone else? We have just started the 8259. Remember, we can have so many different questions. This is one of the most basic question which I am asking. Anyone else with any other answer? Okay, so out 51 we are saying that the address of the 8259. Now this should be the content of accumulator. Why we are putting 1001010? This is 92H. Anyone 92H? Control word ICW1 should be 92H. 92H. Anyone? Good. Anyone with 92H? No. Cool. Very good.
सर ICW1 में तो A0 हमेशा
Zero रहना चाहिए. Should be zero. Sorry, it should be 0. So 12H. Okay.
Sir, but A0 is not D7 is not A0. A0 is a different pin.
Wait. Yeah. 80. A0 is different pin. Sorry. A0 is different pin. Sorry. A0 is different pin. It is not D0 or D7. So D0 starts with A7. So here, sorry. Okay. So this is D7 and here you have D0. Okay. So let us cross check with the D7. So D7 provides the information of whether you are using 8085 or not. Okay. So A7, A6, A5 or D7, D6, D5. These three are used together, right? It should be 000001 or 100. So let me go to that slide. This card. Okay, here. Okay, so these three will be used to inform whether you are using 8085 or 8086. Okay, so since you are using 8085, you will keep them all 0. Okay. Okay, so 100 is going to inform that it is 8085. Wait a second. 100 should be, have to check. For 8085 it should be, if we are using 8085, this was clear. Wait a second, why I'm getting confused now? ICW1. ICW1. First three bits are for deciding 8085, but where it tells for 8085 what should be the bit combination. Let me just check. Give me a second. Okay, ICW1. ICW1. Please keep an eye on the slide. Programming it to final ICWs. Okay. ICW1. Here the information. Page starting address of service routines. In 8085 system, 8 interest levels will be generated. Call 8 locations equally spaced in the memory. Provided it is this, okay, it is this, okay, done. But where it tells what should be ICW1, ICW4. Wait a second. ICW3, ICW2, ICW1. Okay, so in ICW1, A765 tells A7 to A5 of interrupt vector address 8085 mode only. So are we providing any address here? Rest of the things then it will be automatically easy. So anyway, let's check the rest of the bits. In our question it says ICW4 is not going to be issued. Okay, ICW4 is not going to be issued. So D0, okay, should be 0. So D0 is 0. Clear, this one is 0. Then after that only 18259 is used, so no cascading, so single. For single it should be 1. So here because it is single it is 1. Then after that interval of 4 or interval of 8. In the question we are mentioning here that we need interval of 8. So for interval of 8 it should be 0. So D2 should be 0. D2 is 0. Okay, and then we are saying the type of triggering that is generated. So we need here in our question it is saying edge triggered. For edge triggered this should be 0. So D3 should be 0. So D3 is 0. Now coming to the next bit. Next bit D4 should be always 1 because it is ICW 1. So this is 1. Rest of the 3 bits 1 0 0 1 0 0. How this particular 3 bits are informing that system is LS byte, least significant byte of the 4 address of IR0 should be 80H. Lower significant byte of 4th address for IR0 should be 80. IR0 80 होना चाहिए. So this is 8-bit system, 8 interval system should be 80. So this should be 1 0 0 IR0 is this here. Okay, IR0 is here. So A7, A6, and then D5 to D0. So rest of the three, all the bits will be 0, and we need it to be 8, 0. So these two will be 1, 0, 0. No, cannot call it this one. A7 to A5 of interrupt vector address. A7 to A5. Okay, because it is 8-bit system, we are going to provide only A7, A6. So it should be, to make it 80, it should be 10. Rest all zeros will be introduced by the 8085. Therefore, we have 1000, then 0000. Okay, so A7, A6, because A5 will not be needed for 8-bit interval. So it will be 10, it will be 0, A5. Clear? Any doubt? What is happening here? Till this part it was clear, okay, that ICW4 is not needed, so this will be provided, this information will be provided by, wait a second, okay, this information is provided by D0, this one is provided by D1, this one is provided by D2, this one is provided by D3, and D3 or D4, wait, yeah, D3, and D4, okay, D4 is always 1 for ICW1. Clear? Now rest of the three bits, D5, D6, and D7. Okay, these three bits are to be used to generate the address. Okay, so in 8-byte system or 8 interval system, we can see from the data sheet that we don't need A5. So D5 can be kept 0. So D5 is 0 because we don't use the 3 bits A7, A6, A5. Okay, we only use A6 and A7. So A7 will be D7, A6 will be D6. Okay, so now the question is saying that for IR0, the address should be 8th. So definitely it should be 1, 0, and D5 will be 0, and rest all the bits will be 0. Okay, because this is 8 interval system, you need only 2 lines for the 8-byte interval system. So it will be 1000. Hmm.
So what is meant by the LS byte of fourth address?
Least significant byte.
Of fourth
Least
address? Fourth
fourth
address
address.
means?
This is something wrong. This is something wrong. I don't think this is fourth address. Of the address for I0 होगा, या इसमें fourth नहीं आएगा, might be typing mistake. Okay, it is not fourth. Okay, least significant byte of IR0 should be 80H. So for 80H, the address is decoded by A7, A6. It is mentioned. Sorry.
And also, sir, it is not least significant byte. It is the most significant byte. A7, A6.
No. Not A7, A6 is not the most significant byte. Most significant byte will be informed by the, you see here, initialization word 2. A8, because you see, wait a second. Okay, ICW will be always the data for A8 to A15, which is for the second INTA. Okay, so for that, this is always A8 to A15. So A7 to A0 is provided by the ICW1. Okay. Okay. So to decode the address, this is combining these two will tell you the address of ISR, interrupt service routine, or ISS. ISS we can say interrupt service subroutine. Okay, ISS. So higher, this is A15 to A8, which we can say higher order byte. Okay, sorry, BYT byte, and then this is your lower significant byte. Okay, this is your higher significant byte. Okay, so for the lower significant byte, when we are saying this is your lower significant byte, okay, A0 to A7, And in the ICW1, the 3 bits A7, A6 and A5 provides the information for the address. Okay, but in 8-bit system we don't need 8 interval system, we don't need 3 bytes, we 3 bits, we use only 2 bits. Okay, for 8-bit system, this is for 4 interval system. When you use 3 bits, for 8-bit interval system we use only 2 bits. Okay, A7 and A6. Now it is mentioning that the interval should be lower significant bytes interval, should address should be 80. So to make it 80, it should be 1000 and then 0000. Okay, so A7 A6 should be 10. Okay, clear? Anyone having any doubt? Remember, higher significant byte is provided by ICW2. Okay, ICW1 do not provide the higher significant bytes address.
Sir,
Hmm.
sir, why are we providing A7 to A5 with the ICW only? Because sir, A7 to A5 combined with the A4 to D4 to D0 will give us the address. And sir, ICW
Wait. You are talking about this particular. Wait a second. Discard. Okay, what is the doubt?
Sir, sir, we are mixing two addresses. Like, sir, we are mixing the content of ICW1 with the address bits. Sir, sir, like there it was like we have to provide 80H. So, sir, we are providing 1002 D6 to D4. But, sir, if we are doing that,
Wait. D6 to D4. Which D6 to D4?
sorry, D7 to D4, sir.
D4.
Yes, sir. So we are doing 1000 instead. Then D4 will become 0.
Wait a second. Who said D4 is getting 0? I told you, wait a second. This is different. These 3 bits are for, look, if you are using 8, wait a second. This is going to become confusing. You see, if you are using 8 interval system or 4 interval system, these 3 bits, first 3 bits, okay, will tell you the information of address lines, and then rest of these lines are provided by the 8259 itself. Okay, so these 3 we have to provide. Okay, this will be automatically entered by the system. For example, now if you want to make an address of suppose 20, okay, you want to give the address 20 to the IR0. Okay, in such case you can see, to make it 20 you have to make it 0 0 1 0. This is 2 and then 0 0 0 0. This is not the control word of ICW1. This actually is decoded by the 8085 that, okay, this is the address for the ISR or ISS, interrupt service subroutine. Okay, I am not calling it ISR because there is another register ISR, interrupts being served, service register. I am not talking about that. Anyway, so these 3 bits, this is actually to decode the address. Out of that, 3 bits are provided by the user, 5 bits are provided by the 8259 in case of 4 interval system. In 8 interval system, 2 bits are provided by the 8259, user, and rest of the 6 bits are provided by the 8259. This is user, this is the 8259. So now the same system, if you want to say 20, it is not going to happen here. Okay, so what you can do is, here you can say, you can play around with these 2 bits only, right? So you can make it 0001 1011. These 2 bits can be either of these 4 options, 0001 10 or 11. Sorry, 11. Okay, and rest you can make the address using the lines of 8259. This 8259 will provide its own data. You cannot change this thing. This is mandatorily provided by 8259. Only you can play around this. So suppose you put it 00, so the address will start from 00 to maximum you can go to 001, so 338. Okay, so if you are using 00, then it will be the maximum address will be 38 3, because 00113 and 81000. If you are saying 11, okay, then it will be f8. So the if you are keeping it 11 d7 d6, then you can go from 1100 to 1111 1000. Clear? So this is f8, and this is I think then 8 4 12. 12 means c 0, I think.
Sir,
Hmm.
sir, but I'm not able to understand how are we telling in IC1 that ICW1 that we are talking about IR0. Like we are just entering the first two bits. So the first two bits can be entered for any interrupt from 0 to 7. So where are we mentioning that this address 80H is for IR0?
Where in this system, 8 interval system. So
Yes,
to
sir.
make it, 80 to, wait a second, I will clear this. If I put 10, okay, rest of the bits are 000, because this is entered by the 8259. So 0000. Now if you
No, sir,
decode
but
it,
why is it entering 0? If A7 and A6 are 10, then
hmm,
any of the combination in the whole
no
table
no 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 no,
can be entered.
how can it be 80? Show me any other combination which will become 80.
No, sir, but we know that we want 80, but the
Ah,
rest of from 8 D5 to D0, the 8259 is it is doing it is
no,
decoding it on
no, no,
its own.
it will introduce 0000. So automatically 80, when it reaches to 8085 now knows that the address is lower significant byte of the address is 80, because ICW, for example, in the ICW2 you have put A15 to A8. Okay, so assume they are all 0000. Okay, up to 8. Then after that, A7 to A0, you have the lower significant byte. Okay, and if you want to introduce 80, so 80 is introduced in this way. Okay, now to make it 80, the user knows that I have to put 10 here. Rest of the bits will be introduced by 8259. It is not the prerogative of the user. User cannot do anything. Now if you decode, it becomes 80, and 80, now the 8085 knows that 80 is the lower significant byte for the ISS, interrupt service subroutine. Any other combination which is making 80? No, there is no other combination which actually points towards 80. Is it any other combination, you tell me? So if we are saying the address should be 80, okay, and the address system should be 8 interval. Okay, so we know that in 8 interval only 2 bits are for the user, rest of the 5 bits, 6 bits are for the 8259. When the question says the lower significant byte should be 80, definitely we have to provide 10 in the A7 and A6. Rest of the bits will be introduced by the 8259. So if you check the combinations, which of these combinations of all these 8 combinations is making 80? The lower significant, if I am saying IR0 should be 80. See here, it is 80. If suppose tomorrow someone says the IR3 should be 80. If suppose, okay, 80. Then in that case, this will be 10. Okay, but this will be not becoming 80 because now IR3 cannot be 80 here. It will be 98. IR3 should be 98. So we can not make uh, what to say, IR3 to be 80 here. So unfortunately, because IR3 in that case D4 is always 1. Okay, so we can make any other combination. We can make it 0, 1 8. We can have 1 8, or we can have 1 1. So 1 1 0 1, that is I think D or C or D, and then 8, C8 or so. Okay, then you can have all this combination 0 0 0 1 1 0 1 1 for these 2 bits, and accordingly IR3 can have all those addresses. Okay, so it is not that you can provide any address to this particular pins. And remember, always remember, the interrupts are ranging from 0 0 0 0 to 0 F F F F. We always keep the interrupt in this particular range only. We cannot go and extend that to any address. Generally we do not do that. The interrupt service routines should be kept in this address range only. So this is how we actually manage the things. It is complicated, but this is how the system works. For example, wait a second. Okay, this is ICW1. In the ICW1, 3 bits are, if you are using 8085 system, then the 3 bits of ICW1 will tell or will help us to decode the address where we are pointing the ISS, if you are using 4-bit address scheme. Otherwise, if you are using 8-bit address scheme, only 2 bits A6 A7 will be used to help us to decode the address. Clear? In that case, this particular all 8 bits will help us to know whether this will be always 1, triggering address is 4-bit or 8-byte interval, or 4-byte interval, single or multiple, cascaded, okay, or ICW4 will be coming or not. Anyway, to decode the address, we'll be using these 3 bits. 3 bits will be used for 4 interval system, and 2 bits will be used when you are using 2 interval system. Okay, now for 4 interval system, you can use all these 3. So these 3 can be 0 0 0 to maximum 1 1 1. Okay, so rest of the 5 bits, who is going to provide the rest of the 5 bits? Not this is ICW1. Rest of the 5 bits will be provided by 8 2 5 9. And if you are using 4-bit system, 4 interval system, then I told you it is 3 plus 5. So this is 3 plus 5 system. This is 2 plus 6 system. 2 is, or 3 is allowed by the user, and these 2 are provided by the 8259. Okay, so user can play with these 2 or 3 bits only. He cannot go beyond that. So in this case, it can be 0 0 0 to 1 1 1 1. Here it can be 0 0 to 1 1 only for D7, A7 and A6. Rest of the bits are provided by 8259. And in this case, 8259 provides the detail of the IR0 to IR7, because you have IR7 to IR0. These details are provided by the 3 bits, because now you need 3 bits. Which 3 bits? A7, A6, A5 has been consumed. So now A4, or you can call D4, D3 and D2 will provide the details. Rest D0 and D1 and D0 will be always 0 0. This is mandatory. Now these 3 can be 0 0 0 to 1 1 1, pointing to 0 to 7. Any doubt? If you have doubts, please ask, because this will create otherwise more confusions. Any doubt in this system? Remember, ICW1 is different from the way we decode the address. The way to decode the address mostly firstly depends on whether you are using 4 interval system or 8 interval system. Okay, in 4 interval system, 3 bits will be used to provide the details of the address. In 8 interval system, only 2 bits out of A7, A6, these 2 bits will be used to provide the address of the ISR, where the ISR is located. To decode that, we can use this particular thing. That if you are using 0th IR, that is IR0, then these 3 bits tells that okay, it is 000. If you are using 5th interrupt, then these 3 bits are telling the system, or 8085, that it is the 5th IR which is generating the interrupt. Rest of the 3 bits are provided by the user. These 2 will be always mandatorily 0. Okay, and then you can decode the address. Again, here because you have 3 bits, you can range from 000 to 111. You put that range and you can decode what can be the possible addresses of IR0 to IR7. Any doubt? डाउट है तो पूछो भाई, ऐसा नहीं है, इसमें डाउट हो सकता है, मेरे कोई उसमें प्रॉब्लम नहीं है. इफ यू हैव एनी डाउट्स यू कैन आस्क. फर्स्ट आई एम गोइंग टू terminate the class. Wait a second. If you have any doubt, you can ask. I am going to stop the recording.